Okay, kiddos, here goes part 2. We just talked about our lemon battery and all of these terms. So now let's do some multiple choice and short answer. Question 2, list 3 sources from which society generates electricity. So, electricity doesn't just come from the ground. We have to generate it from something. There are several sources. A couple of clean energy sources would be solar, hydroelectric. And so hydroelectric, this is like a dam in a big river where the water spins a turbine to generate electricity. And the other clean energy source for generating electricity would be geothermal. Down at the end of Main Street, there's actually a geothermal plant. The reality, however, is that the United States gets most of its electricity from coal. Okay, so burning coal or burning natural gas, these could be described as fossil fuels. Natural gas. And we also get some of our electricity from nuclear power. So we're taking one form of energy and turning it into another. Electricity happens to be very useful in our homes and businesses, so we use these other sources of energy, which basically just generate heat, to spin a turbine to generate electricity. 3, what type of battery is likely in your cell phone? So that would be lithium ion, okay? And these batteries are sort of the most recently developed and are the most efficient in terms of being able to be recharged several times and holding their charge over a period of time and being light and providing a lot of energy. Question 4, a rechargeable battery acts as a galvanic cell when being used. So when it discharges, okay, galvanic cell or voltaic cell, those mean the same thing. That's just basically a battery, something like what you created, something that generates electricity. A rechargeable battery, however, can be powered in reverse. So when it's being used, and an electrolytic cell when it is being recharged. So an electrolytic cell is basically where we take current or voltage to force the reaction in reverse. Okay. Next page. Following images. So this right here, this is a 9 volt, this is a D, this is a C, AA, and AAA. And you can actually see those things right here, although this one doesn't show it. This is a AAA. All of these, AAA, AA, C, and D, these are all 1.5 volts. Okay, 1.5 volts. A 9 volt battery, of course, is 9 volts, not 1.5 volts. But these are basically the ones that we use in electronics. If you have a little remote control car or those buggies that we played with in class, whatever, they're going to be these types of batteries. So, circle all that are true. So let's see. 9 volt battery is the one with the rectangular shape. That is correct. The AA and AAA both have a voltage of 1.5 volts. That is correct. AAA battery is bigger than a AA battery. That is false. So we would cross this one out and circle these. Those are true. The AAA battery is the smallest. Alright, batteries such as rechargeable lithium-ion batteries have been around for about 1,000 years. That's definitely false. Okay. Rechargeable batteries, especially lithium-ion batteries, have only been around for, let's say, 20 years or so. Archaeologists have found remnants of what looks like possibly a battery from 1,000 or 2,000 years ago. But batteries that actually function as we know them have only been around for less than a century. So that would be false. 7, oxidation. So oxidation, again, use the memory device, oil rig. Okay, it's an expression like SOHCAHTOA or PEMDAS. Please excuse my dear Aunt Sally, right, for remembering order of operations. Oxidation is loss. Reduction is gain of electrons. So, oxidation means loss of electrons. Let's see. The metal gains electron, the metal loses electrons. Battery is being recharged, battery is being discharged. So, oxidation means the metal is losing electrons. In a battery, the cathode is, so let's see. We have a battery. There's going to be a positive terminal and there's going to be a negative terminal. So which is the cathode and which is the anode? Again, I remember here's negative and here is positive. Okay, so negative, I remember anode. Therefore, the other one, positive, is going to be cathode. So let's see what this question asks. In a battery, the cathode is where the electrolyte is. Now the electrolyte would be in here. The voltmeter, if we were to measure the voltage, it would be attached here. Positive or negative terminal. So cathode, positive terminal, like so. Which electrode will gain electrons? Cathode or anode? So this is asking us to connect the dots in a way. We have oil rig. So oxidation is loss of electrons, but we're looking for gain of electrons. So reduction is gain. So whatever terminal is reduced will be gaining electrons. Reduced, okay, will be gaining electrons. And we want to figure out, is that the cathode or the anode? So the one that is reduced is gaining electrons, meaning electrons are flowing to it. This one is losing electrons. So the electrons flow from there to here. Okay? Meaning this is positive, this is the negative terminal, and the positive terminal is the cathode, and the negative terminal is the anode. Whoops, anode. Negative, losing electrons. So, you remember consonants R and C go together, reduction, cathode, and the vowels, oxidation and anode. So, which electrode will gain electrons? Gaining electrons, meaning being reduced, that would be the cathode. 10. Electricity will flow from the, so here we have electrons going from here to here. It's going to flow from the anode to the cathode. Electrons will flow from the anode to the cathode, B. List the following metals, so we're on question 11. List the following metals from highest to lowest on the reduction potential chart. So, highest up is going to be gold probably, so that's AU. And what it says is AU plus 3. Okay, so gold, because it's so high on the reduction potential chart, it is least likely to be oxidized, and that's why gold ends up being such a clean metal and actually a valuable metal. It's because people could make jewelry out of it, and the jewelry year after year after year didn't get tarnished. Dentists also use gold sometimes for replacing teeth. So first, highest up is gold. And then I think we're going to have silver. Let's see, Ag. Okay, good. So next would be Ag, and that's silver. It's also a valuable metal because it's less likely to be oxidized, meaning more likely to be reduced. Reduction and oxidation are reverse processes. Then it looks like we have copper, and the way copper is listed twice, but because we saw it in a reaction with zinc, it would be the +2, not the +1. And then, let's see, what do we have next? Next up, I think, is zinc. Zinc, okay, so Zn +2. And moving down, do we have aluminum in there? No. Calcium, and lastly, lithium. So lithium's way down there, okay, with a reduction potential or a voltage of -3 volts. That's because lithium is way on the left side of the periodic table. It has that one extra valence electron which it wants to give away. It wants to lose an electron. Losing electrons, oxidation. It wants to be oxidized. So the lower on the chart, it wants to be oxidized. The higher on the chart, it wants to be reduced. All right, almost done here. Question 12, which is more likely to be reduced, silver or gold? So this is whatever's higher on the reduction potential chart, and that would be gold, AU. 13, which is more likely to be oxidized? So again, oxidized, what's lower on the chart? Lowest on our reduction potential chart is lithium, so we could say lithium. And lastly, but not leastly, whoops, no, never mind. In an aluminum and lithium battery, what would be the voltage? So, we're looking at the reduction potential chart, and Al, aluminum, we have Al, and it's a +3. That's just the number of electrons it'll give away or take in, is -1.66. Okay, and that's highest. And the lowest is lithium, Li+, and that is -3.04. And so remember, to find the voltage, we do high minus low. So we're going to do the high voltage, even though it's a negative, minus a -3.04. And this will tell us the voltage. I am grabbing my calculator, and remember, subtracting a negative is the same as adding a positive. So I got 1.38 volts for this. 1.38 volts. Okay, again, high minus low. In a zinc and copper, what would be the voltage? So notice how here I indicated +2, just like we did zinc and copper. So copper is highest, and it has, so this is, this is Cu, and 0.34, so that's the high, and we will be subtracting the low. Zinc is lower down on the chart, and it is -0.76. So this again was for the zinc. So we have 0.34 minus -0.76. Subtracting is the same as subtracting a negative is the same as adding a positive. 1.1 volts. Okay, and one more to make sure we can do this. Number 16, in a gold and silver battery, whew, that would be expensive. What would be the voltage? So highest up is gold, AU, and the voltage listed is 1.5. And from that, we are going to subtract AG, which is 0.8. Okay, so subtracting, we do 1.5 minus 0.8 and end up with 0.7 volts. So it's no wonder that we don't make batteries out of gold and silver. We wouldn't get that much voltage compared to these, and because we're using gold, it would be incredibly expensive. Thanks for listening.